Imagine a world without yesterday, today, or tomorrow. Just one endless now. Sounds impossible, doesn't it? Our perception of reality is inseparable from time. It's everywhere, in every change, in every heartbeat, in every moment. Time is the invisible thread connecting past, present, and future. The past has already happened, and the future is yet to come. These two sides of time seem completely different, yet they are deeply connected. The past influences the future, but never the other way around. After all, you can't get wet from a rain that hasn't started yet. That's what defines time. It has a clear, irreversible direction. But why is that so? Why does time always move forward and never backward? This question fascinated physicists in the 19th and 20th centuries, and to their surprise, they discovered that none of the fundamental laws of nature specify which way time should flow. Newton's laws, Einstein's equations, they all work perfectly well if time runs backward. So where does the difference between past and future come from? The answer lies in the concept of heat. In a warm object, say a cup of tea, atoms move faster than in a cold one, like an ice cube. And when these objects come into contact, heat always flows from the warm to the cold, never the other way around. This everyday phenomenon was described by the German physicist Rudolf Clausius, who introduced the concept of entropy, a measure of disorder in a system. When ice melts in a glass of lemonade, its orderly crystalline structure breaks down into chaotic molecular motion. Entropy increases. And according to the second law of thermodynamics, entropy in a closed system can never decrease, only increase or stay constant. But why does this happen? The Austrian physicist Ludwig Boltzmann explained it through probability. Heat naturally flows from hot to cold because that's the most probable outcome. The reverse cold, giving energy to hot, is so statistically unlikely, it practically never occurs. Over time, energy spreads evenly, and temperatures balance out. The second law of thermodynamics is the only fundamental law of physics that distinguishes between past and future. Newton's mechanics, Einstein's relativity, even quantum physics. None of them care about time's direction. Only when heat is involved does time acquire a sense of forward. Imagine a carousel spinning without friction. It would keep turning forever, and you couldn't tell which moment was the past or the future. But in reality, friction exists. Energy turns into heat, and the carousel slows down until it stops. We can clearly see where the past, motion, ends and the future, rest, begins. If time ran backward, the carousel would suddenly start spinning on its own. A clearly absurd idea. This principle governs everything in the universe. A planet can rotate in any direction without breaking physical laws. But a star cannot suddenly start absorbing heat from all directions. That has never been observed. Even life itself, a process tied to heat, moves only one way, from past to future. So there's a deep connection between time and heat. Heat is the key to understanding the arrow of time. The flow of heat is what separates what has been from what has not yet come to be. Of course, our experience of time isn't defined by physics alone. Psychological studies show that humans perceive time differently, depending on the situation. We are the only species capable of imagining the future, of dreaming, and of planning. How do you experience time? Does it flow quickly or slowly for you? Share your thoughts in the comments. This is something that connects us all. If you enjoyed this reflection on time and its mysteries, give the video a like and subscribe to the channel. There are many more stories ahead about the universe, life, and the wonders of human perception.